Okay, I'm on a web page that talks about endothermic and exothermic, and let me show you how it works. If I start off with, right here I've got an ethanol molecule, that's an alcohol molecule, the kind that, like when you ferment corn, you get ethanol, and we put it in gasoline these days. And these are three oxygen molecules. So right here is the chemical equation. We've got CH3, CH2OH, that's the ethanol, and then we've got three oxygen molecules. And then what we can do is we can break the bonds. We can separate all those atoms. So when I start, these are bonded together. Every one of these dashes represents a bond. So when I put in energy, I break those bonds. Notice what happens. These particles are at this level, and then look at how high up the particles are here. So that reinforces the idea that breaking bonds is endothermic, because you have to put in energy to get it to happen. So then, when the chemical change happens, I don't wind up with my original ethanol and oxygen. When I break those bonds and the chemical reaction happens, the new bonds form, I get something else. I get three water molecules and two carbon dioxides. But what's important here is look at how low they are. If I compare that, look at how high these are, and then this, look at how low these are. Compare that all to the beginning. That reinforces the idea that when these chemicals, when these atoms bond, energy has gone down. So that reinforces the idea that making bonds is exothermic, because we've gone down. We've got less energy down here, so that energy had to be given off, and that's the definition of exothermic. Okay, so I'm going to try and reproduce that drawing a little bit and see, turn it into kind of my own little graph here. So I've got, right here I've got my amount of energy, or heat energy, and down here I've got time. So if I start off with, let's use purple. Purple. So if I start off with a certain amount of energy, and I put in energy and break those bonds, and then I wind up with less energy in the products than I had in the reactants, this is exothermic, because I have less energy down here than I did at the beginning. Okay? Now there are other reactions where you start off with a certain amount of energy, and you put in the energy to break those bonds, and then the products that you get are here. When that happens, that's called endothermic. This reaction in this turquoisey color, this reaction wouldn't happen unless you put in heat. So that's endothermic. Okay. Okay, really quickly before I hit 4 minutes, let's give an example or two of these. So we talked about this one. The reactants have this much energy and the products have less. And examples of that are burning things. When you burn stuff, the products have less energy than the reactants. You burn leaves, or you burn gasoline, or what have you. A good example of endothermic, if you start here and the products have more energy, well, what's an example of an endothermic change? Photosynthesis. Sunlight comes in and it gives energy to the process. So you're making these sugars that have more energy than the carbon dioxide and water did that made them. Another example of endothermic would be, how about cooking an egg? When you cook an egg, you have to put in energy to get that chemical change to happen. So there is a graphical kind of representation of endothermic and exothermic.